Hello, everybody. Hope you are all safe and staying back in your home and take necessary precautions. In this video, I'm going to talk about more on standard deviation, and I'm introducing another new measure of dispersion, namely coefficient of variation. So, in the last video, I have described what is a standard deviation, which is I defined it to be the positive square root of the variance. And you can see that it has similar interpretations and similar properties as that of the variance. But I had raised a question: why do we need another new measure called the standard deviation when we already have a variance concept of variance? The answer lies in the property that I had discussed, that is, namely, the effect of change of scale on mean and variance. If we quickly recall that if I have a simple random variable and multiply it by a constant, let us say a, then expectation of ax is a times expectation of x, but variance of ax is a square times variance of x. So at this question, at this juncture, I will raise this query that suppose I multiply a random variable by 2. What will be the effect of on the variance of x? That is, what will be the variance of 2x? So would be 2 times variance of x or 4 times variance of x? And so by the previous property, we see that a variance of 2x is 4 times variance of x. Whereas in case of mean, it was mean of 2x is 2 times the mean of x. So we would like to have a measure of dispersion that would have the similar effect of change of scale. Namely, if I multiply a random variable by a, then I need a measure of dispersion where that measure will also change by a times, not by a square times. That is, in case of variance, we can say the effect of change of scale gets magnified, squared. But we are looking for a measure of dispersion where the effect of change of scale will be there, but it will be proportional. The change will be proportional to the magnitude of the scale. So if I ask what is the standard deviation of 2x, it will be square root of variance of 2x, that would be square root of 4 times variance of x, so it will be 2 times square root of variance of x, so that would be 2 times standard deviation of x. So that is the answer. So, if you look at the square root of variance of ax, where a is any constant, then that is equal to a is a positive constant, then that is equal to a times square root of variance of x. Therefore, standard deviation of ax becomes a times standard deviation of x, where a is any positive constant. So this is the rationale behind defining standard deviation, because then we get a measure of dispersion where the change in change of scale has a proportional effect on the measure. So I can ask you that suppose I have a set of numbers with standard deviation 1, then what is the standard deviation of a new set of numbers, so which is obtained by multiplying each number by 10? So that is a question I think you can easily answer now. And now another important point that I would like you to figure out is this: that suppose from a random variable, given a random variable, simple random variable x, I subtract its means expectation of x and divide it by the standard deviation. Or given a set of numbers x1, x2, xn, so I calculate xy minus x bar divided by the standard deviation of the data. So this process is called standardization. So standardization of a random variable or a set of number would mean that from the random variable or from the numbers in that set, you subtract the mean, divide by standard deviation. I would now ask, what would be the mean and variance of the standardized random variable or the standardized data? So please remember this: standardization means subtracting the mean and dividing by standard deviation. So I'm leaving it as an exercise. Find the given a set of numbers or a simple random variable, after standardization, what is the mean or mean and variance of the standardized random variable or the standardized set of numbers? Okay, now I'll quickly define the last measure that I wanted to introduce today. That is coefficient of variation. This is defined as the ratio of standard deviation divided by mean. In some books, it is multiplied by 100. So standard deviation by mean into 100. Again, a valid question is that again you can see that this is non-negative. This can will be equal to 0 when standard deviation equal to 0, and standard deviation equal to 0 is same as variance of x equal to 0, and that means all numbers are equal, or the random variable, underlying random variable, is like a constant. So interpretations are same. This is non-negative valued, but then why do you introduce this measure? The answer is again in that property of the effect of change of scale. So if you go back to our this discussion just one a few minutes back, what I have said, that the change of if I multiply a random variable by a simple random variable by a, then its mean becomes a times the mean, and standard deviation becomes a times the standard deviation. So now if I take the ratio, you can easily see that the standard deviation of ax divided by the divided by the mean of ax will be a will cancel out from the numerator and denominator, so it will be same as standard deviation of x by the mean of x. So when we take the ratio of standard deviation by the mean, then we get a measure which is free of change of scale. That means now we get a measure of volatility or dispersion or scatteredness present in the data or values of the random variable, which does not depend on the units of measurement. Like for example, I have a set of numbers which represents the heights measured in feet. Now if you change the unit of measurement in centimeters, then the standard deviation will change, right? So I leave it as a food for thought, that what will be the effect. Will it increase or decrease if that is the standard deviation, if I change the unit of measurement from foot to centimeter scale? But the point here is that coefficient of variation will remain same. So I hope you figure this out. This is a very brief and somewhat quick presentation, but at least you can repeat this presentation a few times and try to figure out this important issue, that the standard coefficient of variation is a measure of dispersion which is free of or independent of change of scale. Thank you.